Now we're going to use these residuals to help us find the best line for the scatter plot. So again, I hope that you are doing this for yourself in the applet and not just watching me do it. So it says check the show residuals box in the applet. That's right here. And then you see all these blue lines appear, right? So just to help you understand, each of these vertical lines is a residual. So for example, up in the top right here, this is a negative residual. When I take the observed point, which is underneath the line, and I subtract, so I take the y value, the y coordinate, the height for that, minus the height on the line, I get a negative value. Over on the left end here, here's a positive residual. So these vertical lines, residual, these vertical lines are representing the residuals. So again, it's the distance from the point to the line, that is the residual. And if the point is above the line, the residual is positive. If the point is below the line, the residual is negative. Now, your applet should show this SAE, that is the sum of the absolute errors. So the thing is, you remember what absolute value is. Those residuals that are negative, we just find their absolute value. So we're adding up all the lengths of these vertical segments, and any that were negative, we're going to make them positive and then add them all together. So when I sum or add those up, I get, in my case, 58.40. And unfortunately, we're not in class to do this together, but probably somebody got a better one than I did. And you might challenge yourself and move your line around until you get a better one. Right, so the SAE stands for sum of the absolute errors, error meaning the same as residual. In other words, how far off is the observed from what the line says. That would be the error or the residual. And we take them all in absolute value. Now, what we can use instead, and what is used in practice, is the sum of the squared residuals. Now, if you click the Show Squared Residuals box, it's really interesting because when we square, it actually makes squares. You see all the square boxes. That's actually what squaring means. So we take the distance from the point to the line, and that is the length of the side of a square, and then we draw the rest of the square based on that. And so this SSE, sum of squared errors, error, another name for residual, is actually adding up the errors the areas of all of these blue boxes. And in my case, I got 271.04, and you got what you got. And again, probably some of you did better than I did, and that's great. Okay, and so the squared residual takes the residual distance from the point to the line and makes that the side of a square, and then shows you what the square looks like. And each of those squares has an area, and we sum up those areas to get this thing called the SSE. And that is how we're going to measure how good our line is. So part B says, now continue to adjust your line until you think you have minimized the sum of the squared residuals. So I'm going to go back to the applet and try as best I can, it's hard on my tablet, to grab this line, and as I move it, I'm looking at this show squared residuals number, and I see it's changing, it's going down, then it's going up, and it looks like the smallest I could get is 238.15. I think that's the best I can do. So I'm going to write that down here. 238.15 for my SSE. And again, I don't know if anybody got lower. And then the new equation that goes with that, 40.14 plus 0.96. I got to write it down before I forget. 40.14 plus 0.96 times foot length. and that is height hat. By the way, I don't think I mentioned before, when we put the hat on, that means predicted, right? So height hat means predicted height, what the line is predicting. So the key idea here, what we call the least squares regression line, minimizes the sum of the squared residuals. So it puts the line in a place where when you make all those boxes and add up the areas, you get the smallest possible number.